What is up, everybody? Long time no see. No, I'm joking. If you guys were on InfoSec Unplugged earlier, I literally just got off the air maybe about an hour ago. If you haven't checked that out, please go check that out. We had a great conversation with Dara J. Footman. Um, it was a spirited conversation. Just talking about our frustrations with certain things that was going on in the tech field, especially on Twitter, and we just wanted to address a couple things that we wanted to put a stop to, I guess. But that's that show. That's that video. So go check that out. Today or tonight, we're going to look at day 9 of the TryHackMe Advent in Cyber. So that's why I'm here. I tried to do a video earlier, try to record it, but I just wasn't feeling it. It just wasn't working right. But I want to keep the streak going. So we're just gonna get right into the video. So let's do it. So let's see here. Just want to fix my stuff, make sure that we're good. There we go. Okay. Actually, you guys don't need to see me. Whew. All right. So starting out, you guys know the routine by now that we don't watch the video, but I'm really tempted in watching this one because Alhazred did the video. So shout out to him. If you guys haven't seen his stuff, go check out his channel on Twitch. He does a lot of TryHackMe and CTF streams. And he keeps it really fun and entertaining for the people watching. And he has great stories to go along with the information, as well as just a wealth of knowledge. So with that, we'll just go right into the story. Again, if you guys like what I'm doing here, please like, comment, share, subscribe. Uh, leave comments in the comment section below. Help boost that algorithm. And subscribe to the channel if you haven't done so already. Click the bell for notifications so you could be notified whenever I go live with this video, other videos like my how-to videos or InfoSec Unplugged. So, and any support would be greatly appreciated. So, getting into the story, it says McSkitty recently found out that a large amount of traffic is entering one system on the network. Use your traffic analysis skills to determine what kind of activities Grinch Enterprises are performing. Then there's a little download task files, but we don't need to worry about that because we're going to be using our attack machine. As a matter of fact, let's go up here and start the attack box while we wait. And then we'll just close this out and we'll get to reading some of the stuff. So in this task, we will walk you through the required skills and knowledge to perform a basic packet analysis using Wireshark. Packet analysis is a technique used to capture and intercept network traffic that passes the computer's network interfaces. Packet analysis may also be called in with different terms such as packet sniffer, packet analyzer, packet protocol analyzer, or network analyzer. As a cybersecurity individual, gaining packet analysis skills is an important requirement for network troubleshooting and communication protocol analysis. Using network analysis tools such as Wireshark captures network packets in real time and displays them in human readable format. It provides many advanced features, including the live capture and offline analysis. And then it goes into we're going to use the Wireshark to analyze unencrypted protocols like HTTP, DNS, and FTP. Excuse me. Running on empty here. Let me just move this stuff over here. All right, cool. So where are we? Right here it says we're just requiring some stuff that basic networking, like the TCP/IP stack, TCP handshake, and OSI model. If you haven't familiarized yourself with those concepts, you can check out the networking room here on TryHackMe. again, this website is a wealth of information, and most of the stuff is free. If not, you can pay for the membership. I highly recommend paying for the membership because there's so many different rooms to help you gain that knowledge and experience. So, all right, packet analysis tools. There are many tools that are used in network traffic analysis. Each of these tools provide different way of capturing or dissecting traffic. Some offer ways to copy and capture, while others just read and ingest using different interfaces. We're focusing on Wireshark. Wireshark is an open source packet capturing and analysis tool. It's probably the most popular tool that they have out there. It's really easy to use, and I highly recommend if you're getting into cybersecurity or any type of networking, uh, to download the tool and just play around with it. It's free. You can download it on your Windows or Linux machine and just capture some network traffic. Just capture your regular traffic, and then and just analyze it and take a look at it and just see what's going on and get a better understanding of how protocols work and what's happening. And there's a couple other things you can do, which we're probably going to get into shortly. So just continuing on. If you want to do the challenge, it just says that, and then here you can go to this location for getting the PCAP file. And then here's just a command that you would use to run Wireshark and load that PCAP file. So we're just going to check our attack machine and see if it's ready, and it looks like it is. So we're going to open up the terminal. We're going to hit enter to close this one out, and then we're going to open up another terminal, and we're just going to scroll down, and we're going to run sudo Wireshark, and we're going to go into root. Oops, I said rot, but root, which I can type right now. I'm rooms AOC3 day 9 and AOC3 PCAP. And again, when you're typing, you can hit tab to do autocomplete. So if you heard that little drip noise, that was because I was trying to hit tab, and there were either too many files with the similar name, or there was nothing there that matched that. So we're just going to hit enter, and that will start up Wireshark. And now we have that running. And if you actually look, there's already some packets there. And that's pretty much what we just downloaded. So Wireshark usually allows you to run this here to start capturing packets in real time. And then you can do a couple different things up here. But what we're doing right now is we downloaded a file of network packets that were captured previously, and now we're just going to review them for the sake of this room. So down here it tells you the Wireshark interface has 5 major components. We can just break that down now. This is your menu. So pretty much all this is self-explanatory. So file, edit, view, go. This allows you to capture. These are some analysis tools. If you want to look at some statistics or wireless settings or anything like that. Then you have your display filter specification. You're probably going to use this tool here more than anything when using Wireshark, especially today with this challenge. Hold on. Scat sticks. Can you see what's inside the packets? Yes, you actually can. So each packet has some information, but I'm gonna get into that shortly. So this was the display filter. So this is where you can specify what kind of package you want to look for. If you want to look for a specific IP address or a specific protocol, if you want to look for, is it DNS, or if you want to exclude certain ports, you can do all of that from here. Then this is your list of packets. So again, this is all the information here. Again, you see your protocols, you see what's going on, the information, you see the type of packet. So you see there's like a push or an ACK or acknowledge. You see just all this information here. Okay. Uh, Here you see here's the details. So this is back to what you were asking, scat sticks. Um, you can actually open it up a little bit here, and then there's another thing you can do as well. But you see, this is like Internet Protocol 6, Ethernet 2. This is information on the frames, and then down here is more of like the hexadecimal and ASCII stuff. But here's what I was talking about earlier up here with the filter menu. The Berkeley packet filter is the syntax that's used in Wireshark. Uh, Filter packets are, like I said, filtering packets are important because, like I said, it helps you kind of sift through all the stuff that you don't necessarily want to see, and pay attention to what you want, or certain DNS domain names. So you see here Google. Here's one where you're looking for a specific IP address. Down here you could look for a specific port. Are some packets encrypted? Yes. If you're usually you can see you can have encrypted packets when you're searching the internet live. But for the sake of this challenge, scat sticks, it looks like this is all unencrypted. So it's just regular HTTP traffic. It's not HTTP with SSL or TLS. Um, but yes, you can capture encrypted traffic, and you can try to see what's going on. But like I said, it's encrypted for a reason, right? So just following the syntax here, we're looking at IP. You see, to filter an IP address is ip.addr, and then you see the spaces, equals equals, and then space 172.21.2.16. Now, if you hear me, I said space space because when I first started out with Wireshark, I just typed it all out as like one big command, and I was just so frustrated and wanted to like give up because I never could get anything to work. So we're just gonna just look at this now. We're gonna do ip.addr space equals equals space, and then let's just look at 10 10 10 4. So now we can see all the traffic that goes to and from that IP address. So you see here that 10 10 10 5 was a source, and it was sending information to 10 10 10 4. And then you can also do something like this. So scat sticks, back to what you were saying about seeing what's inside packets. You can also do things like you can right click and you can actually follow the stream. So because these are TCP track packets, you can follow the TCP stream. If it was UDP, you could do UDP. If it was an SSL or encrypted stream, you could do that as well. So when you follow that, if you look here, a lot of this is this looks like it's encrypted. So this is what you would see if it was like encrypted or of any type. But then if you continue to trying to find one that has plain text, so let's just clear the filter, and then let's go back up to the top. Nope, that's not a good one either. Let's try. Okay, all right. We'll get around to it because, like I said, we got to do the exercise. Ty says, "Oh, I appreciate that, man. Definitely appreciate the support." So we're gonna try to get through this one. Like I said, it's been a very very long day between work, the podcast, and now we're streaming this. So okay, so basically going back, they did the IP address, and as a result, you can see what's going on. So you can also specify certain protocols such as HTTP. So if the following example shows that you're looking for HTTP packets that have the google.com domain name, so you would put in HTTP contains google.com. So if you were looking for a specific domain name, I don't think there's anything in here like that, but let's see. HTTP contains google.com. Yeah, there's nothing here for Google. Like I said, so didn't expect it, but just for the sake of what we're working on, try to refresh everything. So we just open this up again. All right, let's close this out. Run it again. Okay, cool. Next, you can look for specific ports. So in this example, they use TCP port 3389 or RDP for remote desktop protocol. But then down here, you could also put not TCP port if you want to exclude any traffic that's going to that port. Next, you want to perform any packet analysis. You can use HTTP, FTP, and DNS. So it looks like they're going to start with HTTP first. So if you remember earlier in the week or earlier in the challenge, we were talking about the different HTTP methods. There's get, post, put, patch, and delete. Um, Here you can break down which ones you want to look for. If you want to look for get packets or get methods or post methods or whatever method you want, you can put that information in there in the filter as well. So down here, if you look, the following picture shows all HTTP traffic has been sent to and from the web server. In the first packet, we can see the web request is sent from 192.168. Okay, so that IP address. And we can also see that we sent a GET request without trying to get the admin content. On the next packet, the web server replied with a sender of 404, which means not found. So suppose we need more details on a particular packet. In that case, we can expand using these arrows that I showed earlier. And then you can see the hypertext protocol. So let's go. Let's look for one. Trying to move this thing here. It won't let me. Okay, let's minimize it instead. Okay. All right. Um, okay. Where was I? We can specify the HTTP method. In this case, we can specify to show all GET requests using the following filter. Okay, so let's just use this one real quick. So we hit copy. Let's go to our clipboard, paste it, and then we have to copy it again. So we have to copy it again. Okay, close this out, go over here, hit paste, hit enter, and now we have all our HTTP information. And then if we hit right click, and then you can see you can follow the TCP stream or you can follow the HTTP stream. But if you look here, it looks like we actually got a flag already. But you see here's all the header information. So this is all the request information all the header information that goes in the request. And then this looks like all the reply information. So that's all the header information that's in the reply. And then you look down here, this is just looks like some HTML stuff that goes with the website. So it says the document has moved 1010 for login here. It looks like that's probably like a link or a hyperlink. So it redirects and then it tries to log in again. There's a header. Looks like that's the same flag right there, but this time you get a 200. So remember we said 200s are okay. So 200s are okay. 300s are it's not here. Let's redirect or let's look over here. 400s are you did something wrong or you're not supposed to see this. And then 500s are system or server errors. So that's something wrong on their end. Okay, so here's some more information. Looks like more header and request and response information. So then you have this one here. You could look at the second scenario. You could check the HTTP post request to see what information was put into the web portal. So we'll just close this out real quick and then do this. And then looking at putting this command back in here, but instead of get, we'll do post. We'll hit enter. And then we see here, this is all post data. So if you right click that, hit follow, you can follow that stream. Now you see a post information. Looks like there's another flag, or it's possibly the same flag. Here's a username, McSkitty, and there's a password, Christmas 2021. So it looks like we're finding a bunch of information, just kind of scrolling through this stuff. Looks like there's a login post. So this looks like a web page that you log into. More header and request and response information. So we'll just keep all of this in mind as we're going through. So you follow the TCP stream to get that information. And then it's DNS. So DNS basically is a domain naming system, where basically it translates all IP addresses to domain names. So this way you don't have to remember what the IP address of like google.com is. If we didn't have DNS, we would have to remember a whole bunch of IP addresses to our favorite websites. Imagine having to type in IP addresses to go to like whatever your social media pages or your blogs or whatever, or Amazon or what have you. So that's basically the whole point of DNS, is to translate those IP addresses to names. And DNS usually runs on port 53. But port 53 it's also port 53 on UDP rather than TCP. So the difference between TCP and UDP. So TCP is your TCP follows a three-way handshake. So TCP has your SYN, SYNAC, and ACK. So basically, it sends out a request saying, we have this information, we're looking for this server. The SYNAC basically says, okay, I am the server. Do you want to connect? Then it comes back and says yes, and then it makes a connection, and it makes sure the connection is secure. Where UDP runs on like a best effort model. So UDP just kind of puts that just kind of sends the information, and if you get it, you get it. If you don't, you don't. A lot of VoIP or streaming platforms use UDP as opposed to TCP. So this way, if packets drop there or whatever lags, that's because that's the UDP protocol. Yeah, I love to visit 104 244 42 193 daily. Yeah, that's me too. So if you look here, you go UDP. Let's just type in this in the filter. So we go UDP dot port equals. Remember, you have to do those spaces in between. Otherwise, you'll be like me when I first got into tech and started using Wireshark. And now, when you do that, you see these are all DNS protocols. And if you double click on it, here, it opens up the packet, and now you can kind of look at the packet a little bit more. So you look at the frames, you look at the domain query, you see there's a transaction ID. And what happens with this transaction ID is it tells you that it will tell you if it was like the request or how it was respond. So in this situation, this was the query. And if you go ahead and look at it a little further, you'll see that it was looking for information for TryHackMe.com and is looking for the A record. So it was looking for the naming record of TryHackMe.com. And then I don't want to make sure I'm not jumping ahead or anything like that. Okay, so thus query reference number is used to find the right DNS response to that query. To confirm that, check the field section where it's showing the query response. So if you look here, you check the response. Okay, so basically you would look at that information, and then this is that where is it, that query information that we were looking at earlier. You use that to follow it to get the response of that query. So this transaction ID says you don't need the spaces anymore. Uh, I just do it as a creature of habit now. I mean, honestly, it looks like a lot of that information is when you start typing, it looks like it's already in the search bar, and you can just kind of pick which one you're looking for. But years ago, when I first started doing it, when I first started messing around with Wireshark, I called myself trying to show somebody something, and I think that was like the first time I tried to do like a live demonstration, and realized that live demos are the worst thing you can do when you're trying to show somebody something in this field, because of course when you do a live demonstration, that's when things want to break or nothing wants to work properly. So that was one of my first live demonstration fails. I was like, oh man, look, I've been messing around with this thing called Wireshark, and it allows you to look at network stuff, and sometimes you can even see what's being typed in there. Look, and I never got it to work, and I just remembered feeling so like I was just so upset, and I felt like a failure. But yeah, so anyway, let's just move on. So by double clicking the required packet, we can see that the packet that it has an answer section where it has the answer to our query. So let's just open up the packet again. By double clicking the required packet, I think we did this already. Yeah, we did this already. Okay, so note that the PCAP file might have different IPs or extra. Okay, there are other DNS requests that have been generated in the PCAP file. Now dig more into the DNS queries and responses in Wireshark and answer question 4 in this task. Well, I don't want to jump ahead again, but let's just see something real quick. Follow the UDP stream. Packet TryHackMe. Packet TryHackMe. Let's close that out. So UDP dot port 3. Hit enter. Follow UDP stream. It's the same one. Okay, whatever. Let's just get back to it. FTP. The provided PCAP file has FTP packets, so that's TCP port 21. So TCP port equals. That's why I always record beforehand. Don't even know when they patch it. That's why I always record. Yeah, I usually record earlier on, but I just it I just what it just wasn't working for me today. Like I've either recorded or streamed pretty much um every day of the challenge so far. But like I said, there was just so much going on today. Not that I'm looking for any sympathy, but I just couldn't. It just wasn't feeling it. Oh, looks like some more username and pass information. More username and pass information. So let's see here. The user logged in the FTP server using a username and password and uploaded a secret file. Thus, the current Wireshark filter will not show the packet of the actual uploaded file. Well, yeah, because when you upload a file using FTP, it actually starts a brand new communication stream. So to transfer that file. Instead, we can use the FTP data filter. Okay, so what is that? So this FTP dash data. And then that's our FTP data. And then if we follow that stream, that should give us, yep, okay. All right, so it looks like, again, we're kind of jumping around all over the place. So using the GET request, what directory is found in the web server? So we did that earlier. HTTP post, but we'll just do that. Back up and then hit GET, enter, scroll back up. Where's our... Where is it? All right, let's just follow the stream. Follow the TCP stream. So it says which directory is found on the web server? Was that login? Yep. Okay. What is the username and password used in the login page of HTTP post section? Okay. Login. We're going to again follow the TCP stream. And yeah. Okay. Hold on. It says McSkitty and then password is Christmas 2021. So we'll just do McSkitty, add a colon there, Christmas 2021. And then we'll copy it, close it out, hit paste. Okay. What is the user agent's name that has been sent into the HTTP post section? So the user agent is this flag that we saw earlier. Just move that over here. Remember, user agents in one of the previous challenges, user agent basically shows what device you're using, what browser. It basically gives all the information of what you're doing on that when you're browsing that site, and you can manipulate the user agent to be something else as well. Wait, what? What is the user agent's name? Oh, I have to put the whole thing. So TryHackMe user agent. Here we go. In the DNS section, there is there is a TXT DNS query. What is the flag in the message of the DNS query? Okay, so what was the DNS command again? The UDP port 53. UDP dot port equal 53. All right, cool. Close this out. And now, what does it say again? The DNS section, there is a TXT DNS query. Follow the UDP stream. That's not it. UDP dot port 53. Enter. I want to look for the TXT packet. Um, Trying to remember how. Can you specify the TXT packet? Standard query. These are all responses. Okay. I want this filter. I want. Okay, let's try that again. UDP port 53. Enter. Uh, oh, that's yeah. Okay, I get what you're saying, Leonardo. That was up there earlier. It was the display filter details selected. Scroll down. Okay. But the HTTP, that's just okay. Well, let's see. That's not the protocol, so it would be DNS contains DXT. Nope, that didn't work. Uh, we can specify certain protocols. Okay, showing all packets. Okay, so we did DNS. Then it says to narrow down the search. Contains. Oh, hash, take it off of caps. Nothing there. Okay. All right. I am exhausted. All right, hold on. Let's see. I'm just going to try to look for this real quick. Wireshark. I mean, because it says it right here. It says you look up. Try this again. PDP.port equals 53. This is standard. Just says TryHackMe.com. Let's just do it the hard way. That's all. TCP. Standard query, standard query, standard query response. Packet is one of the last ones after filtering for DNS. Okay. First, let me see if I can. Okay, there it is. Thank you for the help, sir. Or thank you for the help, Leonardo. Okay. This is the flag right here. Appreciate that. I could not see. I could not find it. All right, so we'll do that. Okay, in the FTP section, what is the FTP login? And we actually had that information earlier. Say, no, that was FTP data. TCP port equals. Follow. Okay, so what is the FTP login password? Pass was TryHackMe. That. Okay, in the FTP section, what is the FTP command used to upload secrets.txt? That's store. So STOR. And then finally, at least I think that's final. Is it? Yep. Final question. It's the FTP data. And then if we follow this stream, this is our flag. We hit copy. Paste. What is the contents of the secret.txt file? Oh, I think I just rushed that one. So FTP data. Stop that. Enter. Open up the packet. Was that not the information? That's the information. So what was the problem? Hmm. Okay, so it says in the FTP section, what is the content of the secrets.txt file? Okay, so does it not want the whole thing and it just wants the. It just want that? Ah, there we go. All right. Leonardo, I appreciate the help. I appreciate the help, and we're just gonna. So that was day 9. That was day 9 of the TryHackMe Advent and Cyber event. Um, Another fun box. Like I said, believe it or not, I enjoy doing stuff with Wireshark. Like I said, it's been a long day, but no excuses. We got it done. The streak is still alive, so we're keeping it going. Again, thank you to everybody who was watching. If you like what you see here, you can always like the video, comment in the section below, subscribe to the channel, whether it's on YouTube or Twitch, and just click the bell for notifications for when I go live. Like I said, I do streams like this, I do other stuff, I do how-to videos, and then I also do my podcast every Thursday called InfoSec Unplugged. So be sure to check that out as well. And with that being said, I'm going to log off and get some rest. So you all have a good night, and I will see you tomorrow with either a recorded video or a live stream. It's Friday, so it'll probably be a live stream, but I'll see you guys tomorrow. Take care.